So back to Lewis theory. So we represent valence electrons as dots. And just by convention, we put dots at the most two on a side. So we've got the top, the bottom, the right, and the left. And I think part of this is so that you can look at it and just see how many electrons there are, because it's like with dice, right? You see the 5. I could actually draw that for you. That might be nice. So 1, 2. You see that shape, right? For dice, and you know that's a 5. You don't have to count. You play Monopoly with a 5-year-old. They don't recognize the numbers on the dice. Every roll, they've got their finger and they're counting the dots. That's no fun. We don't want to have to do that. So 2 on a side, easy to see. There's other ramifications of that. We learned from talking about quantum theory that atoms that have 8 valence electrons are especially stable. And we said that was why the noble gases are also stable and unreactive, is because they have 8 valence electrons. 8 valence electrons is called an octet. Just like 8 people singing together, 8 valence electrons is an octet. Of course, helium is one of those little guys. He has to be an exception to everything. He can't handle 8 electrons, so he's just happy with 2. And we'll see that hydrogen, also being one of those little guys, is happy with 2. 2 is a duet. So what we call the octet rule is that atoms will transfer or share. Transferring would be ionic bonds. Sharing would be covalent bonds. Those transfer or share electrons to achieve an octet of valence electrons. Yes?
So the lithium ion would be happy with 2 as well?
Yeah, the lithium ion will be happy with 2 as well, because lithium has 1 valence electron. If it loses that, then it has the same electron configuration as helium. So we often explain it with the 8 and the 2. Really, it's the closest noble gas configuration. That might make more sense to some people. So like lithium and beryllium, their closest noble gas is helium. And so they're going to try to get 2 electrons. Any other questions?